Hello friends, this is Road to IIT and today we are going to see a new topic of the maths, that is logarithmic function. Okay, see, uh, the questions are not directly asked from this topic. You can see a rarely one or two question in past 6 to 10 years question paper from this topic, but still this is a very important topic as it's help you to solve the quadratic equation in integration, in differentiation, in application of derivative, also in area under curve. This is going to help you. So let's see the properties. Let's see what the logarithmic function stands for. Okay, so this is the inverse function of y is equals to a raised to x. See here, y is equals to a raised to x. If you take the x belongs to r, you can take any values of x and you always get the positive value because it's the rational function. The value is always positive, greater than 0. And it's monotonic function, either strictly increasing or strictly decreasing. That means it is invertible. This is the condition for invertible. So this y is equals to a raised to x is invertible. That means x can be written as log y with the base a. This is how we pronounce it, log y with the base a. This is the base and this is the value. See, x belongs to minus infinite to infinite. That means x belongs to r and y belongs to 0 to infinite. Okay, either you can take a 0 or you can take a infinite value. See, infinite is here open interval. Okay, so this is all about logarithmic function. X is equals to log y with the base a. The most important thing is graph. See, if you take any negative value here, you will not get anything, because log doesn't get the answer of negative values. As we see that y is never negative, that means here the domain of log is non-negative integers, or you can say non-negative numbers. This is the graph of logarithmic function. You can see this is the graph of log y is equals to log x. Y is equals to log x. That's why if we take x is equals to 1, then everyone knows that log 1 is equals to 0. So it intersects this axis at here 1 comma 0. Okay, as we know that it intersects this axis at 1 comma 0. Then the value for between 0 to 1, it gives the negative values, and for greater than 1 it gives the positive values. Okay, so this is the graph for y is equals to log x. Please don't confuse. Here it is x is equals to log y. Here this is the graph of y is equals to log x. Okay, and it intersects here. Now in the logarithmic function, the most important thing is its various properties. So let's see that. First, y is equals to log x with the base b is defined for x greater than 0, b greater than 0, b not equals to 1. See, base never can be 1. Why? I am explaining you in the next or after that. See, if log a with the base b is equals to c, then a can be written as b raised to c. This b goes here. The base always goes here. That means b raised to c is equals to a. Then log 1 with the base b is equals to 0. When the value is 1 for any base, the answer becomes 0. Log 1 with the base b equals to 0. When value and the base is equal, answer is always 1. Log b with the base b is equals to 1. Then log a with the base b can be written as 1 upon log b with the base a. The value and the base gonna be changed. Then the multiplication of log can be written as summation. Similarly, summation of log can be written as multiplication, but the condition is base must be same, b. You see, always b. Similarly, the division, here it's division, x upon y. X upon y with the base b can be written as log x minus log y with the base b. Base must be same. These are some known properties, but the most important property is I'm going to tell you is this: log x raised to m with the base e. The power can be go for in the multiplication, and here if there is any coefficient or multiplier, that can be goes to the power. Okay, so here the power goes here, so that means m can be written as log x with the base b. Similarly, this is most important and very rare known property: log x with the base b into n. Then it can be written as 1 upon n log x with the base b. That means you can divide by the multiplier of the base. Suppose you have here base 3 into 2, that is 6. Then 1 by 2 can be comes ahead. Okay, so this is the most important property to use. Then log b raised to x with the base b. As this x goes here, then log b base b is 1. That means answer is x. Similarly for here, b raised to log x with the base b. If the power and the exponent is same, then b gets cancelled out and we left with x. These are the properties of logarithmic function. So keep this all in the mind. Okay. Now, some more important points to remember is this: unity has been excluded from the base of the logarithmic, as in this case. As I told you earlier, the first property, that the base can't be 1. Why? Because if you go for the basics, that means y is equal to a raised to x. If you take a is equals to 1, that is actually base in the log, then you have the multiple answers, because 1 raised to anything comes 1 itself. That means log 1 with the base n will be not possible if n is equals to 1. Okay, log 1 will be 1, will have the infinite many solutions and will not be unique, which is necessary in the functional notation. Log 1 with the base 1 is not a unique. Again, a raised to the log n with the base a. That means a and a gets cancelled out and we left with n is an identifier for all n greater than 0, a greater than 0, a not equals to 1. Example, 2 raised to log 5 with the base 2. This 2 and this 2 gets cancelled and we left with 5. Okay. Again, the number n is 2 is called the antilog of x. The 2 is known as the antilog of x with the base a. Hence, log 512 with the base 2 is 9. Then this 2 can goes here. If we take antilog, then this 2 goes here. So 512 equals to 2 raised to 9. 512 is equals to 2 raised to 9. Okay. So these are the points to be remembered for this function. Again, log n with the base n is equals to 1. As we know that the base and the value is same. Here, log n with the base 1 by n is equals to minus 1. Please remember this is the most important thing. Log n with the 1 by n is equals to minus 1. Logarithmic of to its reciprocal is minus 1. Then log 1 with the base anything is 0. Small points, but still very important. Then these are all about the properties of logarithmic function. Now let's see some examples, small examples. Rarely going to be asked directly, but still, as I told you earlier, this is important to evaluate many type of questions. So let's see this. Find the value of x satisfying log 2 raised to x plus x minus 41 is equals to base 10 is equals to x 1 minus log 5 with the base 10. Now see, if you want to cancel out this log and this log here, then you must have to convert this part whole as a base of 10. Okay, see here you can see 1. So whenever you can see 1, you can written as log 10 with the base 10, because here the base is 10, so I must have to write here log 10 with the base 10. If the value and the base is same, then it comes 1. So log 10 with the base 10 minus log 5 with the base 10. Subtraction can be written as division. That means log 10 upon 5 with the base 10, that is log 2 with the base 10. Okay, and the x is here in the multiplication. Then the multiplier can goes to the power and the power can goes to the multiplier. That means this x goes here. So log 10 with the base 2 raised to x. Now you can see here this whole part and this whole part is now in the symmetrical form. Log 10 and log 10 here, if the both values are same, the inner part must be same. That means 2 raised to x plus x minus 41 is equals to 2 raised to x. So 2 raised to x and 2 raised to x is cancel out. So x minus 41 is equals to 0. That means x is equals to 41. See, in log, the questions are very simple. The properties are very less. The numbers of questions are less. But still, the questions are most tricky in this chapter. Because you have to evaluate your mind. How to solve this question and how to start thinking. Because here, if you you can take x here only and only if there is log. This type of log is created. And for that, I write down the one as log 10 with the base 10. This is how you are going to think. Okay. A very tricky questions asked from this. Then this one, log 10, log 10 1, log 10 2, log 10 3 degree, up to log 10 89 degree is equals to 0. Why? Very small question but very tricky. Here from this 89 terms, you will find log 10 45. Log 10 45, that means log 10 45 is 1. That means log 1 and log 1 is 0. So 0 into anything must be 0. Understood? Very easy, very simple. But you have to open your mind always. Okay? So this is all about today's video. A very important topic to cover. That's why I'm covering this. The exam is very near. So for revision, I only recommend you to go for my first video and start watching all the 70. I uploaded 70 to 72 videos. Watch all the videos from start to the end, and that will help you a lot. It covers the theory, past year JEE problems, JEE mains, JEE advanced, AIEEE extra problems, and all other stuffs. Okay, so watching all the videos will revise you. It takes only one day and you will going to revise all the things. Okay, so thank you for watching this video, and if you like this video, don't forget to share it and hit that subscribe button. Thank you.